orthocenter constructions. An orthocenter is the point of concurrency where the altitudes of a triangle meet. And if you don't remember what an altitude is, it's basically creating a 90-degree angle with one of the sides, a segment, and its opposite vertice. So my first triangle, I attempted to make an equilateral. I didn't really like measure it and perfect it, but I just tried to draw it as an equilateral. For this one, we're going to do 3 triangles. We're going to try to make an equilateral, and then we're going to do a right triangle, and then we're going to do an obtuse triangle. Because just like with the circumcenter, depending on the type of triangle, this could fall outside of the triangle. So what we're going to do is basically what we're doing is constructing a perpendicular, not a perpendicular bisector, but a perpendicular line from a point not on the line. This was one of our original constructions we had at the beginning of the year. So what I'm going to do is, depending on how you draw your triangle, you may have to extend your triangle. So it's going to be kind of weird. First thing I'm going to do is I'm just going to pick a side. So I will use, I'm going to use this side and this vertice. So I'm going to make sure that my needle, which is that little circle on the inside, lines up with one of the vertices. Just pick a vertice. And what I'm going to do is I'm going to open up. What I'm looking for is I want to swing this so that way it passes. See, it's passing that segment. And then you want it to pass through the segment on the other side. But I actually look like I picked a side that's too short. So if this is the case, let me show you what it should look like. If I use this vertice and I close this up, it swings through this side, and then it comes back through that side. That's what you're looking for. But in this case, and it may just be yours as well, this side may not be long enough. So I'm actually going to extend it lightly. You may not need to extend yours, but in this case, I need to extend mine. So I'm going to put my needle on my vertice, open up so that way it swings through here and it swings through here. I was really supposed to lift up and make 2 vertices, but I knew this was going to be close. So one of my intersections is right here, and it looks like one of my intersections is like right here. So maybe I didn't need to extend necessarily. Now what I'm going to do is I'm going to take my needle, I'm going to put my needle on each one of those intersections. And I'm going to make an arc on the outside. I'm going to move my needle to the opposite intersection, make an arc on the outside. What this is doing is not creating a perpendicular bisector of a segment, but it's creating an altitude. An altitude is a 90-degree angle. It's basically the height of the triangle. So this is creating a 90-degree angle. So there's my 2 little 90-degree boxes. And I'm going to do the same thing with another one of the sides. So this time I want to use this vertice because this one's pretty. I'm going to open up so that way it swings through and then back across. So make an arc there, make an arc here. And then what I'm going to do is I'm going to use this intersection and this intersection to make arcs on the outside. Using the opposite vertice to the segment and that intersection I just made, creating a altitude. See, in this case, it looks like a perpendicular bisector, but in the other case, it didn't. Orthocenters, technically, if it's perfectly equilateral, the circumcenter and the orthocenter would fall on the same exact point. So this right here, and if you did the third side, they would also pass right there, is called the orthocenter. So now we're going to see what an orthocenter looks like on a right triangle. This is definitely where we're going to need to extend. So here's my right triangle. Try your best to make a right triangle. You don't have to stress super much about it being perfectly right. First thing I'm going to use is the segment that is the hypotenuse, just because that one will actually create a perfectly nice 90-degree angle that I won't have to extend aside. So using the opposite vertice from my hypotenuse, I'm going to open up so that way it swings through the hypotenuse and then back through the hypotenuse. Using those two intersections, I'm going to create an arc on the outside. This is creating an altitude of the triangle. I'm going to connect this vertice with that intersection. 2 points create a line. And this should realistically be a 90-degree angle to that segment. This is clearly not a bisector. Those are not equal segments, but it is perpendicular. So I'm going to do the same thing to one of the other sides. I'm going to just use this one. So this is where if you were to line up your needle and you made an arc going through here, and I'll just show you as well, there is no space on the other side for that arc to connect to anything. So you don't just pick a random spot. You're gonna have to extend the base of your triangle. So that way you actually have an intersection to go off of. And if you're thinking ahead of time, since this is an altitude, you're looking for it to create a 90-degree angle. Cough, cough, hint, hint. If it's a right triangle, and if your right triangle is perfectly right, then the altitude should actually just fall on that side. See? So I'm using the opposite vertice and that intersection. I didn't measure mine, so mine's slightly off, as you can tell. And this also tells me that I need to extend this because I want to know where these altitudes cross paths. So mine is not perfectly right, but I also don't have a protractor at home. This is called the Orthocenter. Now we're going to do an obtuse triangle. Here's my obtuse triangle. This is clearly obtuse. And I'm going to use the longest side as my first segment, just because this will actually be nice. I won't have to extend anything. So using my vertice and its opposite side, I'm going to make sure that this swings and hits both sides of my triangle, my segment. Hits there, hits here. Now I'm going to use my needle and make an arc on the outside. Switch intersections, make an arc that intersects with the arc I just made. This will connect with the opposite vertice, creating an altitude for the triangle. And I'm going to extend this just because the last triangle I needed to go back and extend it anyways. So this is creating a 90-degree angle here. Now I'm going to pick another one of my sides, and I'm just going to use this one. So the opposite vertice to this side, if it shares this vertice and this vertice, it's the vertice that's not being used. So the opposite vertice is all the way over here. So I'm going to open this. Oh, I have to put my needle here. You're putting your needle on the vertice that you're using. Ooh, it's gonna be not cute. So this obviously is not gonna hit. Oh, my paper's not big enough. I'm gonna have to use a different one. Let's try to use this vertice with this side. Okay, this will be better. So I'm gonna make an arc here. That intersects with that side right there. And then obviously I'm going to have to extend this side because it's gonna hit somewhere all the way over here. So I'm gonna extend this side. Hopefully I made my arc long enough. using a straight edge, follow the side of the triangle. Oh. Okay. Where this intersection is and this intersection is, I'm going to make arcs that come out. They cross paths here, and I'm connecting it to the opposite vertex. If this is the segment I'm using, the opposite vertex is going to be over here. So I'm connecting this intersection with this opposite vertex because it's creating an altitude, a 90-degree angle to this vertex. I'm looking for where this altitude connects with this altitude. So I need to extend this to see where they cross paths. And this is just another type of center for triangles, which makes no sense because it's like, this isn't even on the triangle. How is this a center? So this right here where they intersect is the orthocenter. Have fun.